Think about a butterfly moving through the air. Its flight is one long, unbroken motion. In the natural world, everything happens in this kind of smooth, continuous flow. But computers have a problem. They can't actually see a continuous flow. They are digital, which means they can only process information that is broken down into separate, countable pieces. To a computer, that smooth flight is an invisible blur. To bridge this gap, the computer has to act like a camera. When you take a single photograph, you aren't capturing the whole flight. You're freezing one tiny, static moment in time. If you take a whole string of these photos very quickly, click, 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 you get a series of snapshots that represent the motion. This process of picking out specific moments from a continuous flow is called sampling. Without these frozen moments, the computer would have nothing to hold on to. It needs reality to be chopped up into these tiny individual pieces before it can even begin to understand what it's looking at. When engineers describe this process, they use a few simple labels to keep track of the butterfly and the camera. This diagram shows how we map that flight. This smooth, curving line represents the butterfly's real path. We label the time it takes as t, and the path itself as x of t, which is just a fancy way of saying the signal that changes as time passes. Now we start our camera. These vertical lines represent each time the camera clicks. The specific wait time between each of those clicks is called the sampling interval. The speed of that camera, how many times it clicks in a single second, is the sampling frequency. For high-quality music, a computer might click 44,000 times every second to make sure it doesn't miss a single vibration of sound. This speed is critical. It determines how much of the real world we actually save and how much is lost in the gaps between the clicks. Once the process is done, the smooth path disappears and only the snapshots remain. We're left with a numbered list of data points, 1, 2, 3, which we call n. This list of numbers is the only thing the computer actually sees. But if our camera is too slow, we run into a mechanical limit. If the butterfly flats its wings faster than the camera can click, we start to lose the truth of the motion. You've probably seen this in videos of car wheels, where they appear to be spinning backward. Because the camera is missing so much of the action, the snapshots create a false version of reality. This specific kind of digital distortion is called aliasing. It's what happens when your sampling speed can't keep up with the real-world movement. To prevent this, there is a strict math rule you have to follow. This diagram shows that your camera must click at least twice as fast as the fastest movement you want to capture. If a wing flaps 10 times a second, you need at least 20 snapshots a second to see it correctly. If you don't follow this speed limit, the list of numbers you give the computer will be wrong. You aren't just losing detail, you're creating a digital file that actively lies about what really happened. This isn't just a metaphor. Inside your phone is a tiny chip called an analog-to-digital converter. It's the real-world camera that's constantly clicking away, turning the air vibrations of your voice into a series of snapshots. Each of those snapshots is then given a specific numerical value, like a score on a scale. This is how we turn a physical sound into a clean list of numbers. When you want to hear that sound again, another chip reverses the process, smoothing those jagged numbers back into a continuous wave that moves your speakers. You might ask, why go through all this trouble? Why take a perfect flowing sound and chop it into a clunky list of numbers? A moment of wonder. Because computers are essentially high-speed calculators. They can't think about a sound wave, but they can do math on a list of numbers. Once reality is a list of numbers, a computer can instantly sort through them to pull a single voice out of a noisy crowd, or recognize a face in a blurry photo. Sampling is the essential bridge. It's the tool that allows our digital world to finally hear the analog one, giving artificial intelligence and modern machines the ability to understand the universe one snapshot at a time.